Hey, welcome to Algebra. Mr. Jorgens here. We're going to be going over section 3.3 on function notation today. We call it 3.3 part 1. We're going to have a part 2 tomorrow. Make sure you pay attention as there will be questions for you to answer along the way. Alright, for example 1 here, we're going to evaluate f of x equals negative 4x plus 7 when x equals 2. In a problem like this, this notation here, f parentheses x, is going to be pronounced f of x, and we can kind of think of it as the y value of function f when evaluated at a given x is how that kind of means, but we can kind of think of it as like the y, and we're going to try to solve for that output y value here for a given input value of x. Remember, in functions, x's are the inputs and y's are the outputs. So in this case, we're given an x value of 2, and an x value is an input. We're going to input it in for x in our original problem and then solve it out for what f of x would be. So working this one out, we're going to have f of 2 because 2 is my input value, so it's going to go in for x in both places. So f of 2 is equal to negative 4 times x. Remember, if you ever have a number and an x right next to each other, there's an invisible multiplication dot in between. So negative 4 times 2 plus 7. And then we're going to be able to work out the right-hand side doing PEMDAS. So parentheses, then exponents, then multiplication and division, then addition and subtraction. So we're going to start with our multiplication step, which is right here. Negative 4 multiplied by 2 makes a negative 8. And then once I multiply, I can add and subtract. So to finish off my problem, I'm going to have to do negative 8 plus 2. So go ahead and work that out. Negative 8 plus 2, what would that make? Sorry, I should say negative 8 plus 7. Negative 8 plus 7. This problem right here is going to give us our answer. So negative 8 plus 7, what would that make? So looking at my plus minus chart there, I have 7 positives and 8 negatives, so I have one more negative than positive. So my answer is going to be that the function when evaluated at negative 2, so f of 2 is equal to negative 1. Alright, our second problem here is one for you to try. It's just like example 1, but just with different numbers. We're going to evaluate f of x equals 2x minus 5 when x equals 6. Go ahead and enter your answer for f of 6 when you're ready. Alright, so let's go through our solution on this one. A big part of these problems, the inputting and outputting problems, is all on the setup. So we need to input 6 in for x in our problem. And when we do that, I kind of have it set up f of 6 equals 2 times 6 minus 5, and all of those blue slots there are representing the x values. 2 multiplies 6 makes 12. Remember, I'm going to multiply before I subtract, so I'd have f of 6 equals 12 minus 5, and 12 minus 5 makes 7. So my output value for an input of 6 would be 7. Again, that's not f times 6, it's f of 6 is equal to 7 on this one. Alright, let's take a look at our second example now. Example 2, for an f of x equal to 2x minus 5, let's find the x for which f of x equals negative 7. You realize this problem goes backwards, or is reverse of our first type of problem that we looked at in this section. Because instead of giving us an x value, it's giving us an output value. Because remember, f of x is like the y. So our f of x here is like our y. And so I'm going to plug in my 7 for my y, or my f of x, and then I'm going to solve it out for x. Again, this can get a little tricky because sometimes people don't replace that whole f parentheses x with just one number, but since it's telling us that exact f of x is equal to negative 7, what I'm going to do is when I rewrite my problem on the left-hand side, I'm going to put in exactly negative 7 in for f of x. So negative 7 equals 2x minus 5. And when I do that, I've set up a two-step equation where I'm going to have to move the 2 and move the 5 in order to solve for x. So in an equation like this, we worked on solving them a lot in chapter 1, and we touched on it throughout chapter 2 as well. Obviously, I'm going to have to move the 2 and the 5 away from the x. So which number am I going to move first? Am I going to move the 2 first or the 5 first in solving this equation? Good, hopefully you said we're going to move the 5 first. Again, we undo subtraction by addition. So by adding 5 to both sides, and when I do that, negative 7 add 5 is going to make a -2, because if I think of the plus minus chart, 7 negatives and 5 positives, the balance is going to be 2 more negative than positive. So I have -2 equals 2 times x. So I'm going to undo my multiply 2 by dividing 2. And then when I do that, I get x equals -2 divided by +2 makes a -1. So my input would be -1. That would lead to an output of -7. Alright, here's the second problem for you to try. We're going to let f of x equal 6x plus 9, and again they're giving us the output value of 21. So find the x value for which our output f of x is equal to 21. Just a hint, that 21 number is going to be our left-hand side, right? So when we go to input 21, we're going to be inputting into the left-hand side. Go ahead and work that out, and when you find that x value, you can go ahead and enter it as your answer. Alright, so again, that's our setup. 21 replaces the left-hand side. It's equal to 6x plus 9. And go ahead and work that out. I got to move 2 numbers away from x. So I'm going to move the 9 first, and then I'll move the 6 afterwards. So I'm going to undo my add 9 by subtracting 9 to both sides. When I do that, I get 12 on the left is equal to 6x. Then I can divide through by 6 to both sides. 12 divided by 6 is 2. So my x is equal to 2 on this one. That means that if I input 2 into my function f of x equals 6x plus 9, the output value will be 21, as noted in the original problem. Alright, this is a good start on section 3.3. We will continue with part 2 on section 3.3 tomorrow.